convince yourself that this was probably deposited by a freshwater or brackish water regime because there are stream channels in the Morrison. So that means there was water flowing there and it was on a continent rather than in the bottom of an ocean.
Where did the name Morrison come from?
I don't know. But Morrison, yeah. Morrison Formation is probably the most extensively studied Jurassic unit because of all the dinosaur bones.
Yeah.
It's a more weather-resistant formation, and it erodes more slowly than the Morrison Formation beneath it. They're located. It is where they are capped by this very resistant sandstone formation, and that is it's called the Dakota sandstone. It was.
Ah, is it?
Yep. It was deposited by a freshwater. Some of the oldest Cretaceous in this area, and it overlays the Jurassic. It's not a continuous natural sedimentary formation. There's an unconformity. There's a period of time where either the deposits were not sedimented between the Morrison and that Jurassic, or they were there and they got eroded out, and then that was sedimented on top of it. So it's called an unconformity. Yeah, there you can see it. Like here, what I'm showing you here, this is a sandstone that's part of the Jurassic era formation. And then actually in this sandstone formation is microbes. Cyanobacteria, photosynthetic algae, and others have actually moved into the rock and colonized it. And you can see the green. Here's an example. I don't know if someone wants to look at it. Yeah. But it's actually colonized the rock. And this is a good field site to consider when you're trying to understand potential niches for microbes on Mars. Oh, yeah. Places where microbes, if they were to exist on Mars, would need to be in places that would be protected from radiation, but close enough to the sun where they could get light and so on to photosynthesize.
Yeah.
So by crawling in a rock as a microbe, you have a place to live. It acts as a substrate in which to grow. It filters the light so that harmful radiation does not penetrate in, but because this is a sandstone and the grains are somewhat transparent, light can still get through the grain and then allow the organism to photosynthesize while it is in the rock. Yeah. Yeah, this is a really good specimen. You can see how the organisms are right near the surface, but not actually on top of the surface.
So that's endo?
Yeah, that is an endolith.
Okay. And they would contribute to flaking off of the outer layers of sandstone?
Sure, it certainly could be something that would promote, to a certain extent, weathering, but the effects of weathering that these have are probably a lot less than just the freeze-thaw process and, and that kind of thing. This is an excellent specimen. So this site and others have been studied by scientists who are interested in characterizing the microbes that live in the rocks.
Yep.
Because it's thought that if you knew where to look for an outcrop, something like this on Mars, if you had the right tools and technologies, you could come up to it and knock a block off and look and see if there's microbes in it.
Yeah.
It's hard to see from space.
Yeah.
It's even hard to see with your eyeballs right here, but when you get real close and you knock a chunk off, you can see it immediately.
So do these give off any kind of chemical?
All natural byproducts of respiration and photosynthesis. So yeah, you could look for that, but it's so minute.
It's not a great quantity.
Yep.
This is going to sound like a stupid question, but has there ever been any work done to determine why they bother? You know, it's the harshest possible environment.
Why are they here? Yeah.
You have to crawl inside a rock.
That's a good point. You know, and how did they get here? Where did they come from? You know, those are questions that are sort of unknown and remain unanswered. But part of the reason why I think they are able to be here and why they are here is because this doesn't move as much as that. This sandstone is more or less stable for long periods of time and creates a better niche for a microbial ecology. Whereas the siltstones and the mudstones are much more easily and more rapidly eroded and wash away. It's also possible that there may be some mineralogy here that's useful at producing some trace nutrients.
So this isn't really, I mean, this is not a harsh life for these creatures. It's just life, isn't it? This is just the way it is.
Yep.
Oh.
When
I
it's
mean, they're not going,
when it's
oh, maybe we should try over there.
yeah, this environment is selecting for that type of organism.
Yeah.
Whereas that environment does not select for that environment. So it gives you a sense of, if you landed the rover over there and you had all the tools to find life and you start digging, you wouldn't find it. You were 20 meters too far from the site. So that's why site selection and the ability to move around on a planetary surface is so critical.
Environmental adaptation.
Right.
It's really interesting.
Yep. This is the endolith site, and I wanted to show that to you. And if you go up to the ridge and look at the sandstones, they are also colonized with microbes if you get in the right spot. It just kind of depends where you look. Bring up a good point. The particle size is important. And out here, there's the particle size of like clays and stuff is extremely small, and sandstones are a lot larger. So you can interpret a geologic formation, a rock, if it's a sedimentary feature like these, fairly rapidly in terms of the type of water environment that it was deposited in. If it's a large grain, it was moved by rapidly flowing water, or if it's a small grain, that was cemented out or deposited out in extremely slow or no flow water. So that's why when you look at the Morrison Formation, it's these very narrow bands, and they're parallel to each other, and if you feel it in your hands, it feels very fine powder. So you know that the fineness is an indicator of the environment it was deposited in, so you can immediately infer, yes, this was probably very slowly flowing water or a lake type sediment environment. Whereas the Dakota sandstone that's on top of here, when you see it, there's big rocks, there's actual pebbles in it, and they're rounded. And so you know that had been deposited by very fast flowing water.
And can you tell whether it was saline sea or fresh?
Yes. A good way to do that is to taste it. If there's any kind of salts, you can taste it. And that's one thing, if you can learn something about the salinity, if there's any actual salt left.
It's amazing how the constancy of it.
Yeah, exactly. And where it's real thick, you know, the same kind of environmental, the flow regime was the same for a long period of time. Top of an even older colluvial plain sediments that are very finely bedded, called the Somerville Formation. And
Is this Somerville?
Yep.
Okay, recognisable by that fine bedding.
Yep.
Thin bedding.
And there's bits of gypsum and so on that's in it, so you know it's an environment that shallow, evaporating
Sea.
Yeah. So it's incredible. This is quite a spot.
Somerville is under.
Boulder.
It's under the Morrison.
Yep. So part of the other reason why I wanted to come up here is for some reason there's a whole bunch of these translucent rocks that are just scattered all over the top right here. This sort of big round boulder over here. I don't know if this is probably a place where people, Native Americans, made tools or whatever. But there was a specimen here that I wanted. Oh, here it is. This rock was sitting right here, like that, and I pick it up, and there's just a rich colony of cyanobacteria growing underneath it. So here's a rock on top of a rock that has organisms growing underneath it.